friends, welcome you all to Think Maths. This is class 11 Maths, chapter 1, sets. In this session, we are going to discuss practical problems on union and intersection. So that is nothing but, there is a formula to find number of elements in A, number of elements in B, and number of elements in A union B, and number of elements in A intersection B. So those formulas we are going to apply. Now let us find, let A and B be finite sets, and if A intersection B is equal to 5, that is null set. There are no elements in A intersection B. So then number of elements in A union B will be equal to number of elements in A plus number of elements in B. So this is the way to represent in a Venn diagram. So there will be two circles. So this is the set B and this is set A. And this is union. If this A intersection B is empty, that is no element common to A and B. So then this set A and B will be disjoint. A, B. So then A union B is nothing but number of elements in A plus number of elements in B. So suppose there are some elements in A union B. Then number of elements in A union B will be equal to number of elements in A plus number of elements in B minus number of elements in A intersection B. So we have to subtract the elements that are common to A and B. So this small n denotes number of elements. Okay. Now we have the sets A minus B, A intersection B, and B minus A. Already we learned that these sets are disjoint. That is, they don't have anything in common. So if you look at this Venn diagram, A minus B. So A minus B is, this portion is A minus B. So that is this portion. So this portion is A minus B. So we should leave the part of intersection. So this portion is A minus B. What do you mean by A minus B? That is the elements of A that are not in B. It is called A minus B. So this, what is B minus A? That is elements of B but not in A. So this portion will be in A. So we should not include this portion. So B minus A will be this portion. So this is B minus A. So if you look at this, B minus A minus B, they don't have anything in common. So they don't overlap. B minus A will not overlap with A minus B. A minus B will not overlap with B minus A. And also A intersection B will not overlap with A minus B and B minus A. That means A minus B, B minus A intersection B, they all will be disjoint. So this is the part of A minus B in the circle. So this is the part. So this part will be A intersection B, and the remaining, this part will be B minus A. So A minus B, A intersection B, and this is B minus B. So they don't have anything in common. So they are all disjoint. So if you join everything, you will get A union B. So also n of, that is number of elements in A union B, can also be written as number of elements in A minus B plus number of elements in A intersection B plus number of elements in B minus A. So there is another formula for number of elements in A union B. So if there are three sets, then n of A union B union C is nothing but n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection B minus n of A intersection C plus n of A intersection B intersection C. So because how to draw the Venn diagram for three sets? It will be in this form. 1, 2, and 3. So A, B, C. And this rectangle will be the union of all the three sets. So n of A, number of elements in A. So we have in A we have this common also. So this is the portion where A intersection B will be there. So this will also be included. This portion is A intersection B intersection C. So that is this portion will be A intersection B intersection C. So all the other three are overlapping are. So this portion is, I'm sorry, this portion is B intersection C and this portion is A intersection C. Okay. So this portion A intersection B, A intersection C and B intersection C. So in all the three we have A intersection B intersection C. So we have to add it here. Okay. Now let us do the problems related to these formulas. Now example 23. If x and y are two sets such that x union y has 50 elements, x has 28 elements and y has 32 elements. How many elements does x intersection y have? So what are all given? If x and y are two sets such that x union y has 50 elements, that is n of number of elements in x union y, it is 50. Next, x has 28 elements, that is a number of elements in x is 28, number of elements in y, it is 32. What we have to find out, how many elements does x intersection y have? That is, we have to find out n of x intersection y. So what is the formula we know? We know number of elements in x union y is equal to number of elements in x plus number of elements in y minus number of elements in x intersection y. So what is x union y? It is 50. N of x is 28. N of y is 32 minus n of x intersection y. What is 28 plus 32? It is 60. So 60 minus n of x intersection y. Now we have to find out this number of elements in x intersection y. So it is in RHS, we will take it to LHS. So minus will become plus. So number of elements in x intersection y will be equal to what is in RHS? 60. In LHS, we already have 50. When it goes to RHS, this plus 50 will become minus 50. So 60 minus 50 is 10. Therefore, number of elements in x intersection y is 10. Okay, there are 10 elements common to x and y. Which you understood? So moving on to the next example. Example 24. In a school, there are 20 teachers who teach mathematics or physics. Of these, 12 teach mathematics and 4 teach both physics and mathematics. How many teach physics? So, what are all the data given? 20 teachers who teach mathematics or physics. So, this R indicates union. Okay, so R indicates union. So what is given? So let us take the teachers in mathematics as M and teachers in physics as P. So now what is 20? It is who teach mathematics or physics. That is number of teachers who teach mathematics R means union. So N of M union P is 20. Next, of these 12 teach mathematics. That means number of teachers who teach mathematics is 12. and 4 teach both physics and mathematics. So this and indicates a teacher can teach both physics and mathematics. So it is intersection. So and is for intersection and R is for union. So number of teachers who teach mathematics and physics is 4. What we have to find? How many teach physics? That is, we have to find n of p. So let us use the formula. N of m union p is n of m plus n of p minus n of m intersection p. What is n of m union p? It is 20. So 20 equal to n of m is 12. N of p we need to find out minus n of m intersection p is 4. Now it is 12 minus 4. 12 minus 4 plus n of p. What is 12 minus 4? It is 8. So 8 plus n of p. So n of p is in positive sign. So no need to change the side. Keep it as such. Now change the 8 to left hand side. Already we have in left hand side 20. So 20. This plus 8 will become minus 8. 20 minus 8 is 12. 12 is equal to n of p. Or number of elements in p is equal to 12. So therefore number of teachers who teach physics is 12. Okay. Now p is equal to 12. If both are equality, if you change your equality as such, there will not be any change. Okay. So here we took only 1 here. Only we took 8 here. So plus 8 will become minus 8. Here we just interchange. When you interchange the sides, the values negative sign will not come. Okay. So number of teachers who teach physics equal to 12. Okay. So moving on to the next example, example 25. In a class of 35 students, 24 like to play cricket and 16 like to play football. Also, each student likes to play at least one of the two games. How many students like to play both cricket and football? So it is about cricket and football. So let us name the students who like to play cricket as A and students who like to play football as B. So what is given? Totally there are 35 students. That is n of A union B is equal to 35. So it is given n of A union B is equal to 35. 24 like to play cricket. That is number of students who play cricket. Cricket is denoted by A. So n of A is equal to 24 and 16 like to play football. So n of B is equal to 16. Okay. So also each student likes to play at least one of the two games. So that is each student likes to play any one game, either cricket or football or both. So every student plays. Therefore, n of A union B will be 35. Now, what is the question? How many students like to play both cricket and football? So, both and means it is intersection. They are asking for n of A intersection B. Now, use the formula n of A union B is equal to n of A plus n of B minus n of A intersection B. What is A union B? How many are there? 35. N of A is 24. N of B is 16 minus N of A intersection B. What is 24 plus 16? It is 40 minus N of A intersection B. Now this is in negative sign. So bring this to the left hand side. So it will become positive. So n of A intersection B will be equal to, in the left hand side we have 35. Already in right hand side 40 is there. This 35 will become minus 35 as we change the sign. So 40 minus 35 is 5. That is, number of students who like to play both cricket and football is 5. Who like to play both cricket and football is equal to 5. Okay. I hope you can understand this problem. So moving on to the next example, example 26. In a survey of 400 students in a school, 100 were listed as taking apple juice, 150 as taking orange juice, and 75 were listed as taking both apple as well as orange juice. Find how many students were taking neither apple juice nor orange juice. Okay. Now let us take the total number of students 400 as universal set. So let the universal set denote the, that is U denote the set of surveyed students. Now, what are they? They are taking apple juice and orange juice. So let us take the students taking apple juice as A and number of students taking orange juice as B. Now what are all given? So number of elements in universal set is equal to 400. Okay. 100 were listed as taking apple juice. So number of students who take apple juice equal to 100. 150 as taking orange juice. So number of students taking orange juice equal to 150. 75 were listed as taking both apple as well as orange juice. So, both apple as well as, that means they take both apple and orange juice. That is and. So, it is intersection. Okay. So, N of A intersection B is 75. Now, what is the question? Find how many students were taking neither apple nor orange juice. So, neither apple means they don't take apple. So, that is complement of A. Nor orange juice means they don't take orange juice also. So, they don't take apple juice and they don't take orange juice. That is A dash intersection B dash. So we have to find out number of elements in A dash intersection B dash. So what we know about this A dash intersection B dash by De Morgan's law? A dash intersection B dash is nothing but A union B whole dash. Okay. So if it is intersection, the opposite side union will come. So A union B whole dash. So number of elements in A dash intersection B dash will be equal to number of elements in A union B whole dash. So how will you find number of elements in A union B whole dash? So let us take the Venn diagram. Okay, so A, B. So this is A union B. The complete thing is A union B. So what will be A union B whole dash? It is nothing but from the universal set, we have to take A union B. So A union B whole dash is nothing but from the universal set, we have to take out A union B. Okay. So from the universal set, we have to take out A union B. That will give A union B whole dash. That is complement of A union B. So this is the complement of A union B. So from universal set, take out A union B. It will give you A union B whole dash. So number of elements in A union B whole dash is nothing but number of elements in U minus number of elements in A union B. So we can write it as number of elements in universal set minus number of elements in A union B. So how many elements are there in universal set? It is 400. How many elements are in N of A union B? Is it given? It is not given. So let us use the formula n of A plus n of B minus n of A intersection B. Okay. So it is 400 minus, what is n of A? It is 100, and n of B is 150, and n of A intersection B is 75. So 400 minus 100 plus 150 is 250 minus 75. So 400, what is 250 minus 75? It is 10 minus 5, 5. There will be 4, 7. So it is 175. So what will be 400 minus 175? It will be 225. That is, students who are taking neither apple juice nor orange juice equal to 225. Okay, number of students taking neither apple juice. So let me write the answer. Number of students taking neither apple juice nor orange juice is equal to 225. So these students, they don't take both the juices. So it is n 225. Okay, children, understood? So moving on to the last example. Example 27. There are 200 individuals with a skin disorder. 120 had been exposed to the chemical C1, 50 to chemical C2, and 30 to both the chemicals C1 and C2. Find the number of individuals exposed to chemical C1 but not chemical C2. Chemical C2 but not C1, chemical C1 or chemical C2. So here there are 200 individuals with a skin disorder. So total number of individuals are 200. That is, universal set is 200. So let you denote the universal set consisting of individuals suffering from the skin order. Okay. Now what is given? There are two chemicals C1 and C2. So let us take the chemical number of individuals exposed to chemical C1 as A and number of individuals exposed to chemical C2 as B. Now what are the data given? They have taken the data of 200 individuals. So number of individuals in universal set equal to 200. So totally they have taken the survey of 200 individuals. So 120 had been exposed to chemical C1. That is, number of individuals for exposed to chemical C1. So it is denoted by A. So N of A is equal to 120. 50 to chemical C2. C2 is denoted by B. So N of B is equal to 50. And 30 to both chemical C1 and C2. So it means intersection. So N of A intersection B is 30. So what is the first question? Find the number of individuals exposed to chemical C1 but not C2. That means chemical C1 Chemical C1 is in A but not C2. That means A minus B. So they are asking for A minus B. So A minus B is nothing but number of individuals exposed to chemical C1 but not in C2. So it is B. So we have to find out number of elements in A minus B. So what is A minus B? From the Venn diagram, we can see N of A. What is N of A? N number of elements in A is A minus B plus A intersection B. So if you add both this A minus B and A intersection B, you will get number of elements in A. So number of elements in A is A minus B plus A intersection B. So number of elements in A is equal to number of elements in A minus B plus number of elements in A intersection B. Okay. Now we have to find out A minus B. What is number of elements in A? It is 120. So it is n of A minus B plus number of elements in A intersection B. It is 30. So keep this number of elements in A minus B in right hand side. In left hand side we already have 120. This plus 30 will become minus 30. So 120 minus 30 is 90. So 90 is equal to n of A minus B. So that is number of students exposed to chemical C1 but not C2 is 90. Okay. For the first one it is 90. Next for the second one, what we have to find? Chemical C2 but not C1. That is, we have to find out number of individuals exposed to chemical C2. Chemical C2 is denoted by B but not C1. Not C1 means we have to subtract A. So this is the place. Just a minute, children. So this is B. Okay, this portion is B. We know that A minus B, B minus A and A intersection B are disjoint set. So, if they are disjoint, they don't have anything in common. So, we can say number of elements in B is nothing but number of elements in B minus A and number of elements in A intersection B. Okay, because A minus B, B minus A intersection B are disjoint. So this is the reason why we can write n of A is equal to n of A minus B plus n of A intersection B. So in the same way, n of B minus A. So to find out this, we are going to use the equation number of elements in B is equal to number of elements in B minus A plus number of elements in A intersection B. This is because B minus A and A intersection B are disjoint sets. So they don't have anything in common. B minus A and A intersection B don't have anything in common. So if you add both, we will get number of elements in B. So now what is given? Number of elements in B is 50. So 50 equal to number of elements in B minus A plus what is number of elements in A intersection B? It is 30. So 50 minus 30 equal to number of elements in B minus A. So number of elements in B minus A is nothing but 50 minus 30 is 20. So for the second part it is 20. Next, third one, chemical C1 or chemical C2. R means it's nothing but union. They are asking for N of A union B. It is simple. You have to use the formula N of A plus N of B minus N of A intersection B. Everything is given. N of A is 120, N of B is 50, N of A intersection B is 30. So 120 plus 50 minus 30 is 20. So 120 plus 20 is 140. So this is the answer for the third part. Okay, understood? So with this, examples on practical problems is over. In the next video, we will see the last exercise in this chapter, exercise 1.6. Okay, children? Thank you. Thank you for watching.